Next up, let's take a look at some string operators. So for string, you have this one operand, which is concatenation. It looks just like a regular plus sign, but this is working on strings. So if you have two strings separated by a plus sign, what you really end up doing is concatenation. So what you do is you tack on the right-hand side operator to the left-hand side operator. Sorry, the right-hand side operand of this plus operator to the left-hand side. So if you have a string ABC and a DEF, you concatenate them, you get ABC, DEF. That's one string. So you want to think about, this is an operation on a type that is string type, and the result is a single string. You get a single string back, and so everything sort of works when we look at this operator and its results. Okay, so it turns out that you can actually use an int on the right hand side of plus operator, and that's interpreted as concatenating the value of this int. So for example, if int I is 23, and you say in double quotes ABC plus I, you get ABC 23. You get a string back. Now the logic behind this is pretty straightforward. What really happens is you convert this int to an equivalent string, and so that's the key to understanding how concatenation works with not just strings, but things like an int or a double or float. What happens is if you have one of these basic data types or primitive data types like ints or floats or doubles, they are converted to a string, and then the concatenation occurs. Also, if you say, if I is 23 and you say I plus and double quotes one space, you get a new string. So once again, if you have an I on the left hand side of the plus or concatenation operator, and the right hand side is a string, then this I, this int, will get converted to a string, and then you do the concatenation. Okay, if you do something like this, if you have a string plus and then some other sub-expression where you have a multiply, then what happens is you do this first, 2 times I, and if I is 23, it becomes a 46, and then you can do the concatenation operator. I'm sorry, you do concatenation operation. On the other hand, if this was a 2 plus I, this would print out 2 times I equals 223. So if you had a plus over here, you go left to right, and you would say you would see the string 2 times I equals 223. So that is a little bit confusing. So if you want to make sure that you do this operation first, you have to put parentheses around it. And it's always a good idea to do that, to put parentheses to clear up which things you're doing first. Okay, so here's another example. You say 2 plus I plus exclamation. And in that case, you go left to right, you do the 2 plus I, which gives you 25, and then you do 25 plus exclamation in double quotes, and that's a string concatenation, so you get a 25 exclamation. All right. And then you can, here's another example where you do a 2 plus I along with the string. So these things I'm hoping is clear. We say that plus is left associative. That basically just means you go left to right, and then you, for example, here you go left to right. This is a string, and then string plus, sorry, this is an int. 2 plus I is an int, and then you do an int plus a string, which gives you an int. So an int plus a string gives you a string. All right, let's move on to classes. Why use classes, and what does using classes allow us to do? Well, the basic idea is now with classes we can define our own types. So programmers can define their own things. They're not restricted to just ints, floats, doubles, booleans, chars, shorts, things like that. We can set up our own types, and that is really the main thing. That's the key to object-oriented programming. We can set up our own types. Okay, so why use classes? Classes allow us to set up our own types. And what does it allow us to do? It allows encapsulation, and this is a very important idea. Also allows code reuse via inheritance and polymorphism. So if any of these terms are not, if they don't make sense to you right now, just hold on. We will go through all of these terms in a lot of detail in the coming weeks. So I'm hoping within about, I would say within about a week and a half in this course, you should, all of these terms should be clear. If not, definitely ask me. Right, so we will go through those terms as we go along. Classes are collections of similar objects, that is, objects supporting the same queries and commands. So you can have a collection of, you can have a class for dates, for example. So all of the date objects will support the same kind of queries or commands, that is, same kinds of methods. So every object is called an instance of some class. So you can have an instance of the string class, an instance of whatever, an account class, if you set up an account class and set up an instance of it. Okay, so here's a simple example of a class called a counter. This is from the Nino and Hosch book. So if you happen to be looking for it, you can find it in one of the first few chapters in Nino and Hosch. But it's a pretty simple class. So first of all, remember that any class can have one public class which has the same name as the name of the file. So Java requires that if you have a public class counter, this has to be in the counter.java file. Okay, spelled the same way with an uppercase C. In this particular case, we have an int data member count. And remember, the rule of thumb is that whenever you have a data member, always make it private. Always, always, always make it private, unless there's a really good reason for making it anything else. And there are two other possibilities, well, actually three other possibilities. There's public, protected, and then there's no visibility, which defaults to package public. Okay. And remember, we can set up constructors. Constructors have the job of initializing any data members. And in this case, this is really, it doesn't matter whether you do this or not, but it's probably a good idea to put this in. Because remember that in Java, all data members are initialized to 0. So if all you're doing is initializing to 0, even if you skip this, things will still work. Here is what we referred to earlier as a query method. A query method just returns one thing. So in this case, it returns the current value of the data member count. And it's an int, so all it does is a simple thing. It returns count. And a lot of people use the term getters, a get method. And so you might actually see this in some programs. You will see a get count method. Or in the book just happens to use the name current count. You can increment a count, and this is called a command method, and we will see these terms later on too. So increment is called a command method because you're going to do something that will change the value of a data member, and it's a command to do something, and it just so happens it also changes a data member. Here's another command method called reset. All it does is set the value of count to 0. Okay, a nice simple class gives you maybe a quick look at some of the main features of classes. You usually have one public class per file. All data members should be private. And then you have a whole bunch of public methods, including a constructor. So remember, constructors have no return type. And the name of the constructor is the same as the name of the class. Okay. And then the methods, they can all be public like in this case, or some of them can be private or protected if you want. But at least in the very beginning, I think all our methods will be public. Later on, we'll see in cases where we'll want to make some of the methods private. Okay. So when we write classes, we want to somehow model an object's properties. So for example, person. Person should have a name. Those are the properties of a person, a name, maybe a photograph if you have a graphical user interface, and then an ID, let's say, or address, or date of birth, things like that. That's what we mean by saying we're going to model an object's properties. So you can use number values, that is ints, floats, doubles, or you can use strings for name or address. If you have some class that requires a course schedule, it might actually even be an array. You might have arrays of things as data members. Okay, so these would all be reference data types. What are reference data types? That is basically objects. When you see the word reference data types or reference values, think objects. So once again, reference values are objects, and objects in the sense of instances of classes, and as opposed to lowercase objects over here, that refers to real world objects. So for example, a real world date is modeled by an object like this, which is the instance of the date class, and the date class, let's say, has 3 ints for month, day, and year. So in the case of date, we're counting, and so therefore it's probably best to use ints. We're not measuring, really. I guess some ways you can think of it as measuring, but it's better to look at date as a way of counting days and months and years. So it's best to use ints or integer data types. Now you can set up a student class, let's say, an instance of the student class object. An object that's an instance of the student class, and inside it we might have a data member that is an instance of the date class. So this would be, although we would think of this birthday as being inside student, really what's happening is, if you were to look inside memory, what you would see is a reference to, or we denote this with an arrow pointing to another object. These are actually separate objects. Although we think of data members as being inside an object, if you have reference data types, all you really have is a reference, and it's called pointer. This is a technical term used in programming languages. We can say pointer or reference that shows you where this object is in memory. Okay, so the student's value for property birthday denotes or refers to a date object, which is technically it's outside the student object, even though date can be a data member of the student class. Okay, so remember that reference data types are references to objects. So here's a quick quiz. Let's see if you understand how reference data types work. Let's say you have a string x is equal to hello, and then we have string y is equal to x. So now y refers to the same thing x refers to. That's the way to look at it. Now what happens if we set y is equal to null? What is the value of x? Okay, you might want to think about it. You can pause it. You could even try it out in Eclipse if you want. I'm going to give you the answer pretty soon. Okay, so if you paused it and thought about it, the answer is that the value of x is not still hello. It's still a reference to the object's a string object with the string hello in it. So even though we do y is equal to x, all that's happening here is that y is going to refer to the same thing x refers to null. That does not change x. Okay, so that is an important thing to remember. Okay, so next up we'll take a quick look at an overview of a complete program.